How are you all? This is Sukumar. I'm a mathematics teacher. Today our topic is polynomials. Second chapter in CBSE and third chapter in AP State Board. This is the very important chapter. See, what is a polynomial? A polynomial is an algebraic expression. It's an algebraic expression which consists of variables and coefficients. It consists of variables and coefficients, and it involves operations like addition, subtraction, and multiplication. The main condition of the polynomial is the powers of the variables. Powers of the variables must be positive integers. They must be positive integers. See, for example, I will give you an example here. 3x cube minus 5x square plus 10. Here the variable, what is the variable here? Variable is x. So what are the coefficients here? The coefficients are 3, minus 5 and 10. These are the coefficients of x cube, x and x power 0 respectively. So understand, children, topic is degree. Degree of a polynomial. What is the degree of a polynomial? The highest power of the variable. Highest power of the variable is called degree of a polynomial. See, for example, 3x power 5 minus 5x cube plus 5x square minus 10. Here highest power of the variable is what? 5. Therefore, the degree of this polynomial is 5. Understand, students? The next one is degree of a monomial. Degree of a monomial. What is monomial? Monomial means it's a single term. Single term is called a monomial. See, the degree of monomial means sum of all the powers of the variables. Sum of all the powers of the variables is called degree of a monomial. See, for example, 3x square y to the power of 4 z power 6. It is a monomial since it has a single term, right? So what is its degree, children? Degree is equal to 2 plus 4 plus 6, that is equal to 12. So 2, 4, 6 are the powers of the variables x, y, z respectively. So its degree is 12. The next topic is, already you have learned about types of polynomials. See, there is a linear polynomial according to their degree. So what are the types of polynomials? The first one is linear polynomial. Linear polynomial means the degree of the polynomial should be equal to 1. So such a polynomial is called linear polynomial. For example, ax plus b or minus 2x plus 3. These are the examples of linear polynomials. Here the degree is 1. X power 1, x to the power of 1. Right. Next one is quadratic polynomial. Quadratic polynomial. What is a quadratic polynomial? See, a polynomial having the degree is equal to 2, such a polynomial is called quadratic polynomial. That means ax square plus bx plus c, where a is not equal to 0. Of course, this is a quadratic polynomial. So what is the degree of the quadratic polynomial? It's 2. Like that, cubic polynomial. These are all topics you have learned in 9th class. Just I am reminding you whether you understand these topics or not. Cubic polynomial. Cubic polynomial. So for a cubic polynomial, its degree is 3. 3 means ax cube plus bx square plus cx plus d. This is a cubic polynomial. The next topic is, let us learn about 0 of a polynomial. 0 of a polynomial. What is the 0 of a polynomial, children? For some value of x, some value of the variable, the polynomial, the value of the polynomial will become 0. So, for what value of x or variable that value becomes 0 is called 0 of the polynomial. That means, for example, ax plus b. Here, let it be y. Y is equal to ax plus b. So, a into minus b by a plus b. So here these two gets cancelled, minus b plus b. This is 0. That means at x is equal to minus b by a, this polynomial becomes 0. Therefore, x is equal to minus b by a is called 0 of a polynomial. Understand, children? The graph of a linear polynomial is straight line. Straight line. That means it intersects the x-axis at exactly one point here, like this. As you know, this is x-axis, y-axis. You already learned these graphs in 9th class also. Look, here this linear polynomial represents a straight line. It represents a straight line. So it intersects the x-axis at one point. You already know that the degree of linear polynomial is 1. So it intersects the x-axis at one point. The number of zeros of this linear polynomial is 1. Understand, children? Here the degree is 1. Number of zeros is 1. It intersects the x-axis at one point. That means there is a relation between the degree of a polynomial to the number of zeros. Similarly, you can guess, children, quadratic polynomial. So here the degree is 2, therefore the number of zeros are 2. I will draw a graph for this quadratic polynomial. As you know, this is x-axis, this is y-axis. See, this is a parabola. The graph of a quadratic polynomial is a parabola. It's a U-shaped curve. Look, at how many points this parabola intersects the x-axis? Yes, 2 points, here and here. So the 2 points, let it be alpha comma 0 and beta comma 0. Since it is intersecting x-axis, you know that the y coordinates become 0. Therefore alpha comma 0 and beta comma 0. So the zeros, the number of zeros are 2 here. The number of zeros are 2 since this parabola intersects the x-axis at 2 distinct points. Not distinct, 2 points, at 2 points. Next one is cubic polynomial. You can, yeah, you are right. See, it intersects the x-axis at 3 points. Since the degree is 3 here, it intersects the x-axis at 3 points. Therefore, the number of zeros of this cubic polynomial are 3. Number of zeros are 3. Understand, children? So this is geometrical meaning of zero of a polynomial. The last one is the degree of a polynomial is 1 more than the number of terms in it. Actually, the degree of a polynomial does not relate to the number of terms. Does not relate to the number of terms. The third sum is like this. If p of t is equal to t cube minus 1, find the value of p of 1, p of minus 1, p of 0, p of 2, p of minus 2. See, what is the given polynomial here? T cube minus 1. First we have to find p of 1. That means substitute t is equal to 1 in the given polynomial. That means 1 cube minus 1. 1 cube is nothing but 1. 1 minus 1 is 0. So p of 1 is 0. The next one is p of minus 1. What is p of minus 1? Minus 1 whole cube minus 1. This is minus 1 whole cube is minus 1. Minus 1 is minus 2. The third one is p of 0. P of 0 means 0 cube minus 1. That is 0 minus 1 is equal to minus 1. And the last 2, p of 2. That means substitute t is equal to 2 there. That means 2 cube minus 1. 2 cube means what? 8 minus 1. Do you know, children? 2 cube means 2 into 2 into 2. We have to multiply 3 times, not 2 cube means 2 into 3, not like that. 2 should be written 3 times, sorry. Right, this is 8 minus 1 is equal to 7. The next one is p of minus 2. So substitute t is equal to minus 2 in the given polynomial. That is minus 2 whole cube minus 1. So what is minus 2 whole cube? Minus 2 times minus 2 times minus 2. That means minus into minus is plus, plus into minus is minus. 2 2s are 4, 4 2s are 8. So minus 2 whole cube is minus 8. Here it is minus 1. Minus 8 minus 1, that is minus 9. So this is third question. Coming to fourth one, check whether minus 2 and plus 2 are the zeros of the polynomial x to the power of 4 minus 16. So what is the given polynomial? Let p of x is equal to x to the power of 4 minus 16. We have to verify that these minus 2 and plus 2 are the zeros of the polynomial or not. So first substitute p of minus 2. As I told you in the beginning, if the value of this polynomial is 0 at x is equal to minus 2, then this value is 0 of the polynomial. Let us verify. That means minus 2 whole to the power of 4 minus 16. That is 16 minus 16, 0. Understand? Next one is p of 2. That means 2 to the power of 4 minus 16. 2 to the power of 4 means what? 2 into 2 into 2 into 2, like this. We have to multiply 4 times. That means 2 to the power of 4 means 16 minus 16, that is equal to 0. Right. What do you observe here, children? At x is equal to minus 2, the value of the polynomial is 0. At x is equal to 2, the value of the polynomial. What is the value of the polynomial? 0 here. Therefore, minus 2 and plus 2 are the zeros of P of x. Next, fifth question. Check whether 3 and minus 2 are the zeros of the polynomial P of x when P of x is equal to x square minus x minus 6. This is the polynomial. We have to again check these two are zeros or not. Same like fourth sum. You can do yourself. Please do on your notes. Right. Meanwhile, I will do on the whiteboard here. See, the given polynomial, let it be P of x is equal to x square minus x minus 6. Substitute x is equal to 3 now. That means P of 3. Substitute x is equal to 3 in the given polynomial. That means 3 square minus 3 minus 6. That means 9 minus 9. 3 square is 9 no. Minus 3 minus 6 is also 9. 9 minus 9 is 0. Next one. We have already verified. The next one is minus 2. Now we substitute x is equal to minus 2. That means P of minus 2 in the given polynomial instead of x. Right. That is minus 2 whole square minus of minus 2 minus 6. Minus 2 whole square is plus 4 plus 2 minus 6. Therefore 6 minus 6 is 0. Therefore what is the conclusion here? This 3 and minus 2 are the zeros of the polynomial. We can do this sum without substituting these 3 and minus 2 by splitting the middle term. I will do here alternate method. Take the polynomial x square minus x minus 6. So if you split the middle term, minus 3 plus 2 no, that means minus 3x plus 2x minus 6. Take x as common, x minus 3 plus 2 as common, x minus 3. So x minus 3 times x plus 2. Therefore the zeros are 3 and minus 2. This is an alternate method.